So in 10th standard we studied that when electric current flows through a conductor, a magnetic field is produced around that conductor, and we learned that this was first discovered by scientist Ørsted. Then we saw the magnetic field around a straight current carrying conductor, then magnetic field around a circular loop of conductor, then the magnetic field around solenoid, which is like a spring. तर अशा प्रकारे आपण magnetic field already बघितलं. In this chapter you will be studying how magnetic fields are produced by electric current, important foundation for further development will also be laid down. Hence Christian Ørsted was the first one to discover that a magnetic field is produced by an electric current passing through a wire. Later Gauss, Henry, Faraday, others showed that magnetic field is an important partner of electric field. Maxwell's theoretical work highlighted the close relationship between electric and magnetic fields. This resulted into several practical applications in day-to-day life, namely electrical motors, generators, communication systems, and computers. In electrostatics, we have considered the static charges and force exerted by them on the other charges or the test charge. We now consider forces between charges in motion. So you can show that the wires having currents passing through them, if the current in opposite direction, then the wires repel each other, and if the current flows in the same direction, then the two wires attract each other. The force in this experiment is certainly not electrostatic origin, even though the current is due to the electrons flowing in the wire. Overall charge neutrality is maintained throughout the wire, hence electrostatic force are ruled out. म्हणजे जर समजा दोन वायर आहेत एकमेकां शेजारी ठेवल्या, तर त्या वायरमध्ये एकाच दिशेने करंट फ्लो होत असेल तर त्या वायर एकमेकाला अट्रॅक्ट करतात, आणि जर त्या वायरमध्ये ऑपोजिट दिशेने करंट फ्लो होत असेल तर त्या एकमेकाला रिपेल करतात. तर हे जे अट्रॅक्शन रिपल्शन आहे ते ऑब्वियसली इलेक्ट्रोस्टॅटिक फोर्समुळे असणं शक्य नाही, कारण तो जो कंडक्टर आहे किंवा ती जी वायर आहे दॅट इज ऑलवेज इलेक्ट्रिकली न्यूट्रल. सो द इलेक्ट्रोस्टॅटिक फोर्सेस आर रूल्ड आउट. सो मग हे जे कुठले फोर्सेस असतात ते फोर्सेस मॅग्नेटिक असतात, हे या चॅप्टरमध्ये आता आपण शिकणार आहोत. इन 10th स्टँडर्ड वी हॅव स्टडीड दॅट इफ अ मॅग्नेटिक नीडल इज हेल्ड in a close proximity of a current carrying wire, it shows the direction of magnetic field circling around the wire. म्हणजे आपण राईट हँड थंब रूल शिकलो होतो, तुला आठवत असेल तर, की इफ यू होल्ड द करंट कॅरिंग कंडक्टर इन युअर राईट हँड विथ युअर थंब showing the direction of the flow of current, then the curled fingers give the direction of the magnetic field around the conductor. अशा प्रकारे तो राईट हँड थंब रूल होता. हा अशा प्रकारे इथे हा राईट हँड थंब रूल होता की ज्याच्यामध्ये आपल्याला करंट आणि मॅग्नेटिक फील्ड यांच्या डायरेक्शन विषयी सांगितलं होतं. सो हाऊ कॅन वन अकाउंट फॉर द फोर्स ऑन द नेबरिंग करंट कॅरिंग वायर? द मॅग्नेटिक फील्ड ड्यू टू करंट इन वायर 1 at any point is directed into the plane of the paper. Electron flow in a direction opposite to the conventional current, then the wire 2 experiences a force F1 F bar towards the wire 1. म्हणजे हे जर मगाचं जर आपण सर्किट बघितलं आणि ह्याला जर आपण तो हा मॅग्नेटिक फील्डचा राईट हँड थंब रूल जर अप्लाय केला तर आपल्याला असं लक्षात येईल की ह्या लूपच्या आतमध्ये म्हणजे इनसाइड दिस लूप, सो इफ वी कन्सिडर दिस पॉईंट सपोज, या पॉईंटला, तर इथे जर राईट हँड जर आपण पकडला तर इथे ह्या कंडक्टरचं मॅग्नेटिक फील्ड इट इज फ्लोईंग इन टू इट अँड हेन्स we see that the two fields are in this direction, so we can apply the direction and then we can see whether the force is attractive force or the repulsive force. From the above discussion, you must have realized that the directions of V bar, B bar and F bar, they follow a vector cross product. Actually, the magnetic force Fm on an electron with a charge E bar moving with a velocity in a magnetic field B bar is given by Fm bar is minus E in bracket V bar cross B bar, or Fm bar is equal to Q in bracket V bar cross B bar. Justification of this law can be found in experiment such as in point 1a and b. The force described is known as Lorentz force. Here Fe bar is, so if we want to define that magnetic force, we can define it as follows. And that is called magnetic force. It is in contrast with the electric force which we have learned in static electricity. This is called magnetic force. And this is given by Fm bar, the magnetic force Fm bar is Q in bracket V bar cross B bar. Where this Fm bar is nothing but magnetic force, Q is nothing but charge in motion, V is the velocity of that charge, B is magnetic field. So Fm is equal to Q in bracket V bar cross B bar. If both electric field E bar and the magnetic field B bar are present, then the net force on charge Q moving with velocity V will be given by, if both electric field E bar and magnetic field B bar are present, then the total force acting F bar is equal to Q into E bar, that is electric force, Q into E bar plus Q into V bar cross B bar, or you can write it as Q in bracket E bar plus V bar cross B bar. This is total force. ये समझते हैं ना?
होय.
This is electrostatic force due to electric field, and this is magnetic force. So two forces act on it. Justification for this law can be found in experiment shown in the figure, and this figure is and this force is known as Lorentz force. Fe bar, if we call this force as Fe bar, this is electric force, and this is Fm bar, which is magnetic force. There are interesting consequences of the Lorentz law. If the velocity v bar of the charged particle is parallel to the magnetic field b bar, then magnetic force is zero, and if the charge is stationary, then also the force is zero, even if b bar is not zero. तर हा जो फोर्स है मैग्नेटिक फोर्स, which is given by Fm bar, that is equal to Q in bracket V bar cross B bar. The Fm bar is zero if V bar is parallel to B bar, means angle between them is zero. Sin 0 is 0 ना, याची मॅग्निट्यूड किती असेल? मॅग्निट्यूड ऑफ Fm bar is QVB sin theta, isn't it? So if theta is equal to 0, sin theta equal to 0, and that's why the force is 0. So magnetic force is 0 if the charge is moving in the direction of magnetic field. What can we write about it? Magnetic force on a moving charge is 0 if charge is moving in the direction of magnetic field. And the force is also 0 if the charge is stationary, that is V bar is 0. Fm bar is 0 . . 。  . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . or Fm is 0, if V is 0, that means magnetic force on stationary charge is also 0. So from this equation it may be observed that force on the charge due to electric field depends on the strength of the electric field and magnitude of the charge. However, the magnetic force depends on the velocity of the charge and the cross product of velocity vector and magnetic field vector B bar. So consider vectors V bar and B bar with certain angle between them. V bar cross B bar will be a vector perpendicular to the plane containing the two vectors. Thus the vectors V bar and F bar are always perpendicular. How we define the cross product? Suppose the two vectors they lie on this plane. कुठले दोन वेक्टर? V bar आणि B bar. Suppose they lie in these two vectors. So if suppose this is V bar, the velocity vector, and this is B bar, the magnetic field vector, then the direction of the vector V bar cross B bar is given by the screw rule, isn't it? So if the screw is moving from V bar to B bar, that means the screw is moving in anti-clockwise direction. If you move the screw in anti-clockwise direction, where will it move? Upward or downward?
Anti-clockwise.
हाँ, anti-clockwise आपण V पासून B कडे जाताना anti-clockwise जातोय. मग असा जर स्क्रू फिरवला इथला एखादा anti-clockwise मध्ये, तर स्क्रू वरती जाईल का खालती येईल? वरती जाईल. That means the V bar cross B bar vector will be in this direction as per the law of cross product, and that means the force will be in this direction. That means the magnetic force will always be perpendicular to magnetic field and velocity vector. What is the moral of the story? कि magnetic force is always perpendicular to the velocity vector and magnetic field vector. Velocity vector and magnetic field vector. So the magnetic force is always perpendicular to displacement. So magnetic force can never do the work on moving charges. We know that if the force is perpendicular to the displacement, it can do no work, as magnetic force is perpendicular to velocity. Velocity म्हणजे displacement ला पण. It never does any work. It never does any work on moving charges. The magnetic forces may change the direction of motion of the particle, but they can never affect the speed. Magnetic force can change the direction of motion of moving charge. But can never change the speed of the moving charge. Can never change speed of the moving charge. So these are the characteristics of magnetic force.
Okay.
Interestingly, equation leads to the definition of B bar. म्हणजे आता गमतीची गोष्ट अशी की ज्याच्यामुळे आपण म्हणतो की फोर्स अशा प्रकारे काम करतोय त्याचं डेफिनेशनच याच्यातनं दिलं जातं. सो वी हॅव एफ बार इज इक्वल टू क्यू V bar cross B bar, or we can write it as magnitude of cross product V bar cross B bar into a unit vector n cap, and that can be written as q v b sin theta. V is velocity, V is not voltage, don't confuse it with the potential difference. It is not potential difference. q v b sin theta into n cap, where theta is the angle between velocity vector and the magnetic field vector. N cap is a unit vector in the direction of force. So if the force is 1 Newton acting on the charge 1 coulomb moving with a speed 1 meter per second perpendicular to B bar, then we can define unit of B. So if theta is equal to 90 degree, that means charge is moving in perpendicular direction with magnetic field. Charge moving perpendicular to magnetic field. Then we can define F is equal to QVB, isn't it? Sin theta, theta 90, sin 91. So from that we define B to be equal to magnetic field B is equal to F upon QV. We can define B is equal to F upon QV.
Yes.
And from that we can find the unit. 11वी मध्ये आठवत असेल आपण याचं युनिट काढलं होतं त्यावेळी डायमेन्शनल ॲनालिसिस वापरून. इट इज न्यूटन. फोर्सचं युनिट न्यूटन आहे, चार्जचं युनिट आहे कुलम, आणि वेलॉसिटीचं मीटर पर सेकंड, सेकंडवरती जाईल इकडे. सो इन ऑल द युनिट इज न्यूटन सेकंड पर कुलम मीटर. न्यूटन सेकंड पर कुलम मीटर. आणि त्यावेळी आपण गेल्या वर्षी याचे डायमेन्शन पण काढले होते मॅग्नेटिक फील्डचे. म्हणजे एकदा आपण फंडामेंटल युनिटमध्ये एक्सप्रेस करायला गेलो तर दॅट विल बी न्यूटन इज व्हॉट. न्यूटन इज मास इंटू वेलॉसिटी, दॅट इज किलोग्रॅम मीटर पर सेकंड स्क्वेअर, आणि कुलम इज व्हॉट? कुलम इज ॲम्पियर सेकंड, इजंट इट? हां, कुलम ॲम्पियर सेकंड कुठनं आलं की I इज इक्वल टू क्यू अपॉन टी, हो की नाही? रेट ऑफ फ्लो ऑफ चार्जेस. तो क्यू इज इक्वल टू आय टी. आय हे फंडामेंटल क्वांटिटी आहे, आपण मानतो. आपण इलेक्ट्रिक करंटला फंडामेंटल क्वांटिटी मानतो. तर मग कुलम इज नथिंग बट ॲम्पियर सेकंड. सो किलोग्रॅम मीटर पर सेकंड स्क्वेअर म्हणजे झाला न्यूटन. कुलमच्या ऐवजी ॲम्पियर सेकंड, इथे वरती सेकंड आणि खालती मीटर. आणि असं करून आपल्याला मॅग्नेटिक फील्डचं डायमेन्शन्स मिळतील आपल्याला. सो एम किंवा LMT देतो ना आपण, LMT आणि I. L म्हणजे लेंथ, L रेस टू 0, M रेस टू 1, T रेस टू -2, I रेस टू -1. अशा प्रकारे आपण गेल्या वर्षी डायमेन्शन्स काढली होती, डायमेन्शन्स ऑफ मॅग्नेटिक फील्ड. M रेस टू 1, T रेस टू -2, I रेस टू -1. SI युनिट इज ऑल्सो कॉल्ड टेस्ला. तर हे जे आहे 1 न्यूटन सेकंड स्मॉल पर कूलम मीटर, that is called 1 Tesla, 1 T. Unit is Tesla. 1 Tesla is 10,000 Gauss. Gauss is not an SI unit, but it is used as convenient unit. So this is about the magnetic field and its unit. Magnetic resonance imaging, MRI, is used for medical imaging. Requires magnetic field with a strength of 1.5 Tesla even up to 7 Tesla. Nuclear magnetic resonance experiment require a magnetic field up to 14 Tesla. Such high magnetic field can be produced using superconducting coil electromagnet. On the other hand, Earth's magnetic field is much smaller. It is about 3.6 into 10 raised to -5 Tesla or 0.36 Gauss. So this is how we introduce ourselves with the physical quantity magnetic field. A charged particle travels with a velocity v bar through a uniform magnetic field B as shown in the figure. What is the direction of magnetic field Fm due to the magnetic field on the particle? In figure A, आता सांगा बरं की आपल्याला वेलॉसिटी दिली आहे, निगेटिव्ह एक्स डायरेक्शनला, आणि मॅग्नेटिक फील्ड दिला आहे निगेटिव्ह झेड डायरेक्शन. आपल्याला काय काढायचं आहे? आपल्याला व्ही बार क्रॉस बी बार काढायचा आहे. म्हणजे आपल्याला अँटी क्लॉकवाईज स्क्रू पुन्हा फिरवायचा. मग सांग बरं, व्ही बार क्रॉस बी बार. फिगर ए मध्ये व्ही बार क्रॉस बी बार
वाय डायरेक्शन
मध्ये असेल. दुसऱ्या आकृतीमध्ये
एक्स डायरेक्शन. एक्स डायरेक्शन करेक्ट. आणि तिसऱ्यामध्ये
तिसऱ्यामध्ये झिरोच असेल ना, कारण हे यांच्यातला अँगल 180 आहे.
होय.
अँगल 180 साइन 180 0. सो क्रॉस प्रॉडक्ट इज 0. हो की नाही?
हो.
येस. Cyclotron motion. What is a cyclotron? In a magnetic field, charged particle typically undergoes circular motion. Figure 10.5 shows a uniform magnetic field directed perpendicular into the plane of the paper. So it is going into the paper. ठीक है, that is, it is parallel to negative z axis. Figure 10.5 shows a particle with a charge q moving with a velocity v and a uniform magnetic field b directed into the plane of the paper. Correct. According to the Lorentz force law, magnetic force on the particle will act towards the center of the circle of radius r, and this force will provide the centripetal force to sustain a uniform circular motion. Sorry, understanding?
Yes.
V bar is in upward direction, that is positive y direction. Then the magnetic field is going into the page of the paper. Then the force acting on the particle is in the x direction. And that will then give the necessary centripetal force. And it will be responsible for the circular motion of the particle. So this is known as cyclotron motion. The magnetic field is going into the page of the paper, and the velocity vector v bar is in this direction. Then the force acting is in this direction. Here the magnetic force provides the necessary centripetal force for the circular motion. Magnetic force provides centripetal force. So we have QVB is equal to mv square upon r, where r is the radius of circular path. 1v cancels, and then mv, that is equal to momentum, linear momentum of the particle p, and that is equal to qbr, that is equal to qbr. Equation represent what is known as cyclotron formula. It describes the circular motion of a charged particle in a particle accelerator or cyclotron. So this formula is known as cyclotron formula. It describes the circular motion of a charged particle in a particle accelerator. So let us look at a charged particle which is moving in a circle with constant speed. That is, it is moving in uniform circular motion that you have studied earlier. Thus there must be a net force acting on the particle directed toward the center of the circle, that is centripetal force. As the speed is constant, the force must also be constant, always perpendicular to the velocity of the particle at any given instant. Such a force is provided by uniform magnetic force B bar perpendicular to the plane of the circle along which the charge is moving. Now in the three-dimensional thing, if we want to show some vector going into the plane of the paper, we represent it in this direction, this symbol. It means the arrow is going into the paper. So this symbol represents into the paper, that is, vector is going into the paper. And if it is coming out, we show only one dot. So this means coming out of paper, coming out. Cyclotron accelerator. The particle accelerator have played a key role in providing high energy particle beams useful in studying the particle matter interactions, and some of these are also useful in medical treatment of certain tumors and diseases. So what we are going to see is a cyclotron particle accelerator. The cyclotron is a charged particle accelerator accelerating charged particle to high energies. It was invented by Lawrence and Livingston in the year 1934 for the purpose of studying nuclear structures. Both electric as well as magnetic fields are used in cyclotron, and they are used in combination. These are applied to the directions perpendicular to each other, and hence they are called crossed fields. The magnetic field puts the particle or ion into circular path, and high frequency electric field accelerates it. Frequency of revolution of a charged particle is independent of its energy in a magnetic field. This fact is used in this machine. So basically cyclotron consists of two disc-like metal chambers, two Ds, namely D1 and D2, like this. Two Ds are there, two D-shaped, D-shaped containers. A uniform magnetic field B is applied perpendicular plane to the Ds. So the magnetic field is perpendicular to the plane of the paper. The magnetic field is produced using an electromagnet producing a field up to 1.5 Tesla. An alternating voltage up to 10,000 volt at high frequency like 10 megahertz is applied between the two Ds. Positive ions are produced by a gas ionizing source kept at a point O. It is at the center. In the diagram it is shown by point P. The electric field provides an acceleration to the charged particle, and once the ion is emitted, it is accelerated due to the negative voltage of a D, and it performs a semicircular motion within the D. Whenever the ion moves from one D to the other, it is accelerates due to the potential difference between the two Ds, and again performs a semicircular motion. Thus the ion is acted upon by electric field every time it moves from one D to the other D. As the electric field is alternating, its sign is changed in accordance with the circular motion. Hence the ion is always accelerated, its energy increases, and the radius of the circular path also increases, making entire path a spiral. So first we'll write about the structure of this cyclotron. The cyclotron is made up of two disc-like metal chambers. Is made up of two disc-like metal chambers D1 and D2. A uniform magnetic field B bar acts perpendicular to the plane of Ds. An alternating voltage up to 1000 volt and very high frequency like 10,000 hertz. An alternating voltage, AC voltage, very high voltage 10,000 volt, very high frequency 10 megahertz is applied between two Ds. Then positive ions are produced by ionization. Produced by ionization of a gas are kept at point. Are placed at center of Ds. Then the ions are accelerated due to potential difference. So circular motion is given by the magnetic field and acceleration by the electric field. Due to acceleration, by the electric field and circular motion due to magnetic field ions perform spiral motion. Ions perform spiral motion. And we have the formula mv is equal to mv is equal to qbr, where q is the charge on the ion. Then the speed of the particle inside the d, v is equal to 2 pi r upon t. T is the time period. हो गया नहीं? सर्क्युलर मोशन मधला स्पीड आहे हा. T is time period. So from that we get the time period t is 2 pi r upon v, and in that if we put the value of v to be qbr upon m 2 pi r आणि v ची व्हॅल्यू आपण जर qbr अपॉन m जर घातली तर r कॅन्सल. So time period equal to 2 pi m upon qb. So time period of the ion in the cyclotron is 2 pi m upon qb. The frequency of revolution is reciprocal of that. If this is the time period, frequency of cyclotron is 1 upon t, that is qb upon 2 pi m. The frequency of the applied voltage between the two Ds is adjusted so that the polarity of the two Ds is reversed as the ion arrives at the gap after completing one semicircle. That is, we get the resonance condition. The ion do not experience any electric field while they travel within the D, because within the conductor there is no electric field, we have seen in last chapter. So when the particle is moving inside the D, it is not experiencing any electric field, and therefore no electrostatic force acts on it inside the D. Their kinetic energy increases by EV. Here the V is the potential difference. It is capital V. So every time a kinetic energy EV is inserted into that particle, V is the voltage difference. The ion move in circular path with successive larger and larger radius to a maximum radius at which they are deflected by a magnetic field so that they can be extracted through the exit slit. So we can write this, if we write this for limiting condition, at limiting condition R is equal to R exit, that is the maximum radius at which the particle moves out of the cyclotron. So at that point, velocity at the exit V is given by QB R exit divided by M. Sorry, काय आहे? V is QB R exit, yes, divided by M, where R exit is the radius of the path of the exit, and the kinetic energies of the ions. Here the kinetic energy will be equal to half mv square. So it is half m into q square b square r exit square upon m square. 1m cancels. So we have kinetic energy of the cyclotron particle is q square b square r exit square divided by 2m. So with this kinetic energy, the particle moves out of cyclotron. Thus the final energy is proportional to the square of the radius of the outermost circular path. So this is the principle of a cyclotron. Yes, have you understood this?
Yes.
So this kinetic energy expression. Helical motion. So far we have assumed that the charged particle moves in a plane perpendicular to the magnetic field. If such particle has some component of velocity parallel to b bar, या आतापर्यंत आपण असं कन्सिडर करतो की बी बार आणि व्ही बार एकमेकाला परपेंडिक्युलर आहे, पण असे परपेंडिक्युलर नसून जर वेलॉसिटीचा एखादा कॉम्पोनंट बी बारच्या डायरेक्शनमध्ये असेल, देन इट विल लीड टू अ हेलिकल मोशन. सिन्स कॉम्पोनंट व्ही एच बार इज पॅरलल टू बी बार, मॅग्नेटिक फोर्स एफ एम बार विल बी Fm is equal to V bar cross B bar Vb sin 0 0. Thus the velocity Vh will not be affected. Particle will move along the direction of B bar. At the same time, the perpendicular component of velocity leads to circular motion as stated above. As a result, the particle moves parallel to the field while moving along the circular path which is perpendicular to B bar. Thus the path will become helix. Like this the particle will move. Particle accelerators are important for variety of research purposes. Large accelerators are used in practice research. There have been several accelerators in India since 1953. The Department of Atomic Energy, Government of India had taken initiative setting up accelerator for research. Apart from ion accelerators, DAE has developed and commissioned 2 giga electron volt electron accelerator, which is the radiation source for research in science. This accelerator, synchrotron, is fully functional at Rajaram Manna Center for Advanced Technology, Indore. An electron accelerator, microtron, with the electron energy 8 to 10 mega electron volt is functioning at Physics Department, Savitribai Phule University, Pune. So this is about the cyclotron and the motion of the charge in that cyclotron. Have you understood up to this?